Question 3. Consider the expansion 3x squared minus 1 over x to the power of 9. A. How many terms are there in the expansion? B. Find the constant term in the expansion. The first thing we need to do is rewrite the expression. So we rewrite 3x squared minus 1 over x to the power of 9 to 3x squared minus x to the minus 1 to the power of 9. Now we can answer the questions. How many terms are there in this expansion? That's easy. There's always one more term than the power. So A is 10. Part B. Find the constant term in the expansion. Well, the constant term means there are no x values. So it is a constant integer value usually. So the first thing you have to do, let's write down what every term in any binomial expansion is. Well, that can be written as n choose r, a to the power of n minus r times b to the power of r. Now let's write down what we've got. Well, we know n is equal to 9. R, we don't know. We're going to have to find. A is the first term in the expansion, so that's equal to 3x squared. And B is the second term in the expansion, so that is minus x to the power of minus 1. The first thing we have to do is find the value for r. To do that, we want every term in the expression that gives us an x value. So x squared will give us some value of x, and x to the power of minus 1 will. So we can write those out. So we have got x squared to the power of 9, because n is 9, minus r, times x to the power of minus 1 times r, and that has got to equal some value, which we're trying to find, x to the power of 0. Now we can compare coefficients. Let's multiply them out. So I've got 2 times 9 is 18, minus 2r, minus r is equal to 0. Therefore, 18 minus 3r is equal to 0. Therefore, r is equal to 6. Now that we've found r, we can now find the constant term. So now we're only interested in any term that gives us a number. So we have 9 choose 6 gives us a number. 3 to the power of 9 minus 6 gives us a number. Times minus 1. Remember, minus x means there is a minus 1 in front of it, to the power of 6. Now we can work those out. Now, 9 choose 6 is equal to 84. 3 to the power of 3 is equal to 27. Minus 1 to the power of 6 is equal to 1. We multiply those out, we get 2, 2, 6, 8. Therefore, the constant term in this expansion is 2,228. Question 5. Solve the equation log to the base 3 of x squared minus 4x plus 1 is equal to 1 plus log 3 x minus 2. Right, we have a constant term in there. We need to get everything into log base 3. Well, we know that log base 3 is equal to 1. Therefore, we can rewrite log to the base 3 of x squared minus 4x plus 4 is equal to log 3 plus log 3x minus 2. On the right hand side, we have two logs added together. We can use the multiplication rule. So therefore, on the right hand side, we've got log base 3 times x minus 2, which is equal to log 3x minus 6. On the left hand side, we have still got log to the base 3 of x squared minus 4x plus 4. Now we can take our logs away. So we have x squared minus 4x plus 4 is equal to 3x minus 6. Rearrange that to get a quadratic. We get x squared minus 7x plus 10 is equal to 0. That will factorize to x minus 2, x minus 5 is equal to 0. Therefore, x is equal to 5, or x is equal to 2, but we have to reject x is equal to 2 because x minus 2 must be greater than 0 from the expression log 3 x minus 2. So our final answer is x equals 5. Question 7. Solve the equation 9 to the power of x plus 2 times 3 to the power of x plus 1 equals 1. Whenever you see an expression like this, you immediately think of quadratics. I've got to make it into a quadratic. So 9 is equal to 3 squared. So therefore, I can write 9 to the power of x is equal to 3 to the power of x squared. 3 to the power of x plus 1 is equal to 3 to the power of x times 3 to the power of 1, which is just 3. Therefore, I can rewrite this expression as 3x squared plus 3 times 2 is 6 times 3 to the power of x equals 1. I'm going to let 3 to the power of x equals y and substitute in. So therefore, I've got y squared plus 6y minus 1 equals 0. That will not factorize, so I have to use the quadratic formula. So therefore, I've got y is equal to minus 6 plus or minus 6 squared minus 4 lots of 1 times minus 1 all over 2 times 1. So I get y is equal to, it's got to be positive, so therefore I get minus 6 plus 2 root 10 all over 2. So y is equal to minus 3 plus root 10. But that's not the end of it. Y is equal to 3 to the power of x. So therefore, 3 to the power of x is equal to minus 3 plus root 10. Therefore, x is equal to log 3, taking log 3 of both sides to get x, log 3 minus 3 plus root